Here we have an exponential equation and we have to solve for x in this exponential equation. That is, we have to find the value of x. Okay, first let me write the given exponential equation as it is. That is 2 to the 22nd power negative 2 to the 21st power equals to 8 to the x power. Okay, now let me look at the expression we have on the left side. What's the greatest common divisor for the terms we have in the expression on the left side? Is 2 to the 21st power is the greatest common divisor, because here in both the terms I find the base 2, and to get the greatest common divisor, since I have the same base for both the terms, I have to consider the smaller exponent. So when I compare the two exponents over here, the smaller exponent is 21. So from that I decide 2 to the 21st power is the greatest common divisor for these two terms. So since 2 to the 21st power is the greatest common divisor for the two terms in the expression on the left side, it can be factored. Okay, now let me factor 2 to the 21st power from these two terms. Okay, when I factor this 2 to the 21st power from these two terms, so what will I have in the first term and what will I have left in the second term? So for that, I have to divide both the terms in this expression by the one I factored. That is, I have to divide 2 to the 22nd power by 2 to the 21st power negative 2 to the 21st power by the one I factored, that is 2 to the 21st power equals to 8 to the x power. 2 to the 21st power, and here I divide two terms with the same base. Okay, now let's consider the coefficient rule of exponent. What is it? So let's divide two terms with the same base a. So that is, here I divide a to the mth power by a to the nth power. So I divide two terms with the same base a. So whenever I divide two terms with the same base, what I need to do is I have to take the base ones and I have to subtract the exponents, that is m negative n. Okay, now I'm going to apply this coefficient rule of exponent over here. So because here we have the same base in numerator and denominator, we can take the base ones and we can subtract the exponents. Then I'm getting 22 negative 21. And here in this fraction, the numerator is 2 to the 21st power and the denominator is also the same. So whenever I divide two same values, it results 1 equals to 8 to the x power and 2 to the 21st power and 2 to the power of just 1, because when I subtract 21 from 22, I'm just getting 1. So 2 to the first power negative 1 equals to 8 to the x power. Okay, 2 to the 21st power. So when the exponent is 1, we don't have to mention it. Simply we can write this one as 2 negative 1 equals to 8 to the x power. So 2 negative 1 is just 1. 1 times 2 to the 21st power is the same. 2 to the 21st power equals to 8 to the x power. Okay, here I am trying to solve for the variable that is at the exponent. So whenever I am trying to solve for a variable that is at exponent, what I need to do is I have to get the same base on both sides. Once I get the same base on both sides, I can equate the exponents and I can solve for x. So here, what's the base on the left side? It's 2. So the base on the right side is 8. So can I get base 2 on the right side? It's possible, because 8 is a power of 2 and we can write this 8 as 2 cube. Because when I write 2 cube, I have to multiply 2 by itself for 3 times. 2 times 2 is 4, 4 times 2 is 8. So the value of 2 cube is 8. So instead of this 8, we can write 2 cube. Okay, let me do it. So 2 to the 21st power. So instead of 8, we can write 2 cube whole to the x power. Okay, now let's consider the power of a power rule in exponent. That is, let's consider the base a and exponent m. And for the complete stuff, consider another exponent n. So whenever we have two exponents like this, what we can do is we can multiply the two exponents over here, that is m times n. So the same thing we can do for this stuff, because here we have base 2 and exponent 3. And for the complete stuff, we have the exponent x. So we can multiply the two exponents. Let me do it in the next step. That is 2 to the 21st power equals to 2 to the power. When I multiply these two exponents, 3 and x, I'm just getting 3x. Okay, now here two terms are equal with the same base. Whenever two terms are equal with the same base, what we can do is we can equate the exponents. That is, I'm getting 21 equals to 3x. Okay, now to solve for x, what I need to do is I have to get love for this 3, which is multiplied by x. For that, I divide both sides by 3. So this 3 will cancel out. When I divide 21 by 3 on the left side, I'm getting 7. On the right side, we have x. I have solved for x. The value of x is 7.